Okay, so next we need to do the data saving. This won't take long at all. All we need to do is go into the event handling script, and at the top here, let's create a variable for the data store service, which is used to save data. So local data store service equals game : get service data store service. Then we're going to get our data store for this specific game to hold everyone's data. So a local data store equals data store service : get data store, and you need to give a name for this data store. Now the name I'm going to give is my data store. Very, very simple. You can name it whatever you like. But if you change the name of this to something different, then it's going to start using new data. So let's say, for example, you published this game and 10 people came and had their data saved to the my data store, but then you went and changed the name of the data store to my data store 2, and then people rejoined, their data would get lost. So choose a name and stick with it, okay? It doesn't matter, no one else is going to see it. So now that you've got your data store, what we need to do is, because for a data store, each player has their own key, and that key is used to identify their data. So we can save data to a key for each player, and we can identify the key by their user ID. So every player on Roblox has a user ID, and you can find your user ID by going to your profile. It's in the web address link. You don't need to know it though. What we need to do is we need to save the data. So what we'll do is just after the player added event down here, just before the trap debounce, we're going to say game.players.player removing connect function, and player is going to be one of the arguments. So this will run the code inside of it when a player leaves the game. So what we're going to do is we need to create a table for all their data. So there's going to be lots of data that goes in here. For example, their tokens, their equipped trap or skin, the skins that they own, the traps that they own, etc. So what we'll do is we're going to create sub-indexes inside this table. So there could be a table inside this big data table which contains all the skins they have, and another table inside of it which contains all the traps they have. So to create an index in the table, you just have to say the table name and then the name of the index. So for example, if I wanted to save the tokens in the table, I could say data.tokens equals player.tokens.value. And now that is inside the table. So it might look a bit like this. Okay? So that's what it might look like at the minute. So now that we've so what we'll do, we're going to put all this data into the big data table. Then we're just going to save this one table to the data store. So it's saving everything to our key. I have a full video on my channel as well on how to use data stores if you are a little bit unsure, but this will give you a quick intro and brief about them. So now that we've saved the tokens, we need to save the equipped trap and equipped skin. So data.equipped trap equals player.equipped trap.value, and data.equipped skin equals player.equipped skin.value. Then we need to create a subtable for all the skins you have. So data.skins equals a blank table. Now I'm using a capital letter for skins, so a capital S and a capital T for traps. So I've created those two tables, and now I need to use a for loop to loop through the skin inventory table and the trap inventory table. So for IV in pairs, player.skin inventory get children. So because the skin inventory get children returns us a list of all of the skins in your inventory, the I is going to be the number of where it is in the table, and the V is going to be the value. So it's going to be the value that's in there. So V is like the object, the value that's in there, and I is like how the number of where it is in that table. So in a table, it could look a bit like this. It could have Mangler Boy, if that was the name of a skin, Ghost, Piggy, and what was the other one we had? Shaggy Boy. Okay, so the first time So for the first index would be 1, second index would be 2, third index would be 3, fourth index would be 4. So I is just the number of the index that we're currently on. So if we were currently looping through the ghost, then I would be 2 and V would be ghost. Okay? So what we're going to do is make sure you add a do on the end of that for loop. And then we're going to insert into the table, table.insert. We're going to insert into data.skins, and then comma, the name of the current object we're looping through. So the name of the skin that's in that inventory. So if there's 5 skins in the skin inventory, we're going to loop through every single one, and 5 times we're going to insert the name of that skin. So we're going to insert the name of every skin in that skin inventory into the table data.skins. Okay? So this data.skins is going to get populated with every single skin that player will own. Okay? And the way that we get all the skins that they own is because we're basically taking everything that's in the skin inventory folder and cloning it into the data.skins. But we can't just set data.skins to player.skin_inventory:getChildren because you can't save objects to a data store. So what we're doing is we're kind of serializing it so that we're saving their name, not the object. And then when we load the data, we'll be able to look up the skin using its name in the replicated storage. So we can't save objects to data stores, but we can save object names instead. So I'm also going to print the name of V, of the object that we're looping through, so that it will print out all of the objects that get added to that table, so we know that they got saved for sure to the data store. Then I'm going to copy and paste, but change skin inventory to trap inventory. And also data.skins will be changed to data.traps. So make sure that you've changed the skin inventory to trap inventory in the clone in the second for loop, and data.skins will become data.traps. Okay? So we are populating the data.skins and the data.traps folders with the names of the skins and the traps that you own. And now that we've populated this big data table with all this data, we can save that big table to our data store for our specific player who's leaving the game. So data store :set async. That's how we save to a data store. And we need to provide the key. So the key is going to be unique for each player. And the best way to uniquely identify each player is by using their Roblox user ID, because nobody is going to have the same user ID. So we can say player.userid, comma, and then the second argument is going to be the data that we save. So in this case, we're going to save our table called data to the data store. And then what we need to do is we need to wrap it in a pcall in case it goes wrong. So local success error message equals pcall, and then in brackets function with another pair of brackets, and make sure you close it off with an end and a closing bracket. Now a pcall, basically, because sometimes a data store could error, maybe the data store service could be down or something, data stores can error and they can break your whole script, but when you wrap them inside a pcall function, if something goes wrong, it won't break the script, the error won't cause the script to stop, it just simply won't save your data. So instead of losing even more data by breaking the script and it no longer running, so it will no longer be checking for when someone leaves the game, it will just catch the error and it will not break the script. It will just put it to one side and not stop the script for it. So, and it will also, if it was a success, this variable called success, which we've also created, will be true, and if success is false, then there will be an error message, and that error message will be the error message variable that we've also created will be populated, and it will be updated with the error message. So if it was a success, then print successfully saved. Okay, so that will successfully save somebody's data to the data store. Now we need to load the data when they rejoin the game, which is very, very simple. So if you go back to the player added event, so this is when a player joins the game, we can get the player's data from the data store if they have some data, because obviously they could be a new player and there wouldn't be any data for them, but we're going to get it anyway. Local data equals, and this variable, it doesn't have to be called data, I'm just calling it data because it makes sense to. So if you are copying what I'm doing, probably best to use the same name so you don't get confused. Local data equals data store :get async. And we need to provide the key, which we save the data to, so we can look up that key in the data store and see if there's any data attached to it. So the key, which we saved, was their user ID. So we're just going to say player.user ID. Make sure for user ID, you have an uppercase I but a lowercase d and an uppercase U for user. So capital U for user, then capital I but a lowercase d. It is a little bit confusing, but you have to write it like I do, else it will not work. So you do a user ID with a capital D, not going to work. It has to be a lowercase d. So if there is data in the data store, and it should be this table that we saved, because this table is going to have the tokens, the equipped trap, the equipped skin, everything attached to it, because it's going to be inside that table. So if there is data, then it's going to be, then the data variable is going to hold that data. But again, because we're using data stores, it could go wrong. There could be an error when we get the data, so we need to do a pcall. So local success, error message equals pcall function, like this. Make sure you get the brackets on the end of the function, and you also have a closing bracket for the end, like this. So pcall and then open bracket, and you have a function with another pair of brackets, and you have to close the first bracket off there as well. So actually what I'll do is we will define the data variable outside of the pcall, because if we were to define it inside the pcall, then we'd only be able to access the data from inside the pcall. But we want to access the data from outside the pcall as well, because we're only using the pcall for only for this line when we're getting the data, because that's the only time where it could error and it could break the script. So once we have the data, we need to check to see if the data is not equal to nil. So if data is not equal to nil, when it's not equal to nil, we know that there is data there. If the data was nil, nil means nothing, so there's no data stored. So if there is any nil data, then we're not going to do anything. But if there is not any nil data, so that's what this operator is. So if data is not nil, and there is some data, then we want to load this data. So we know that we need to load the equipped trap, we know that we need to load the equipped skin, we know that we need to load the tokens, we know that we need to load the skins inventory, and we also know that we need to load the traps inventory. So we're creating these folders for the equipped trap, for the trap inventory, skin inventory, and the values for the equipped trap, equipped skin, and tokens. But what we need to do is we just need to set the value of these things to the values from the data store. So firstly, we're going to say if data, because remember it's a table, so there'll be our subtables and indexes inside of it. So if data.equipped trap, then equipped trap dot value equals data dot equipped trap, and then we can say if data dot equipped skin. I'm doing them all in an if statement in case they're not there for some reason. So if data dot equipped skin, then equipped skin dot value equals data dot equipped skin. Then we're going to say if data dot tokens, then I'm going to say Piggy tokens. Remember, if you named your variable something different, which is not Piggy tokens, you would be saying the name of your variable here. So if it was cash, for example, Piggy tokens dot value equals data dot tokens, and the same thing. If you saved your tokens as something different, like data dot cash equals player dot cash dot value, you would say data dot cash or data dot money or data dot tickets or something else. But because it's tokens for me, I am loading the data dot tokens. Right, then I'm going to load in the skins. A little bit more work needed, but not a lot at all. If data dot skins, then I'm going to say for I, comma, v, in pairs, data.skins, because it's a table. I'm going to loop through the data.skins table, and I'm going to create a string value, because remember, in the skin inventory and the trap inventory, all it is a folder which will contain lots of string values, and the string values will be named with the same name as the skins and the traps that we own. So it's a way of telling us which skins and traps we own by inserting string values with the same names. So we can just loop through and get the names of all of the string values in that skins inventory, traps inventory. There will be string values. They won't be the actual skins and trap models themselves, but they will be a reference because they'll have the same names. So local val or string value, it doesn't matter, equals instance.new string value val.name. We're going to set the name of the string value to be v, because v is going to be the name of each skin, because it's not going to be v.name, it's just going to be v, because it's a string, it's not an object, because when we saved the data, we saved v.name, not the object itself, not v the object, but v.name. So we saved a string to the data store, because remember I said earlier, you cannot save an object to data store, you have to save a string to a data store. So val.name equals v. We're just giving it the name of the skin that was saved, one of the skins that was saved, because we're doing it for every skin. It's going to loop through, it's going to create a new string value for every single skin that's in that data.skins table, and then we're going to parent it to the skin inventory. So val.parent equals skin inventory. Then all we need to do is just copy this for loop, and same thing again, if data.traps, then, and we're going to loop through data.traps and insert a new string value, name it the name of the trap, but we're going to parent it to the trap inventory. Okay, so there we go. We've just loaded all of the data in. But because we only want to... Now, what I did earlier was in the client shop, after 5 seconds, I called the add skins and add traps. I only want to do this when your data has loaded. So once your data has loaded and we know that it's loaded, so what I'm going to do is I'm going to create a remote event in the replicated storage. A remote event. I'm going to call it send data. So what we can do is I'm going to say game.replicatedStorage.sendData:fire client. And I'm going to fire it for the player who just joined the game. I'm going to send their data as well. So the data we got from the data store, I'm going to send to the client. Okay? And then when that data gets picked up, when that remote event gets picked up, down here, I'm going to get rid of the wait 5. I'm going to change it to game.replicatedStorage.sendData.onClientEvent:connect function. And we don't need a player argument because it's on the client. I'm going to put the add skins and add traps function inside this event. So the traps and the skins are only going to be loaded into our GUI once the data has been loaded. So once the data about our equipped values and our skins that we own has been loaded, only then will I create all the frames in the skins and traps frames and show them only once the data has been loaded. And we know the data has been loaded because after all of this equipped trap setting and adding all the skins to the skin inventory and the trap inventory, only then do I fire the send data remote event. So that will only fire once the data is loaded, and it'll only be picked up once the data is loaded. So, moment of truth. Let's see if this will work. First things you need to do is right click and click on publish to Roblox as, if you haven't already. Make sure you publish it as a Roblox game. Okay? I'm going to try again. Publish to Roblox as. Doesn't want to work for some reason. Okay, there we go. Restarted Studio and now it seems to work. So I'm going to publish it or update a already published game. Just make sure it's published to Roblox. And then click on Game Settings, go to Options. This is very, very important. Make sure that Enable Studio Access to API Services is turned on. Okay, turn that on. Enable Studio Access to API Services on. Click Save. And then you'll be able to test your game and your data source in Roblox Studio. Okay, now I recommend that you test it in a proper game. Okay, I recommend you do that. And that is what I'm going to do. And if it takes ages to load the server, don't worry. It's probably because Roblox is under a lot of load. It did take me a while to open this server up. But if I go and purchase a few things, let's purchase the Ghost and the Shaggy Man and the Invisi Trap. Let's equip the Invisi Trap and equip the Shaggy Man. Let's leave the server and rejoin. Okay, moment of truth, and I'm just going to say this as well. Data stores, it is likely you might have problems with it. and it's one of the hardest things to debug. Okay, so it looks like our data hasn't loaded here, so I'm going to check the developer console just to see if anything's gone wrong, and just to make sure, let's do game dot players dot alvin underscore blocks dot equipped trap dot value. Let's print that out just to see if anything was saved. Okay, so it says the equipped one was the invisi-trap. So what I think's happened... Yes, okay, I know what's happened. So it has loaded the data, but it's just not it's not updating the cost text or the button image. So because look, when we click on the button, when we click on the, let's go back. When I click on the Shaggy Man, it instantly equips it, and this turns to owned. So it knows that we already own it. It's just that we haven't coded it on the client. So when we first insert these frames, it doesn't automatically update to say it doesn't load the equipped or owned values in the GUI. It updates the values, but it doesn't update the GUI. So let's have a look at that now. So I've got a very, very simple fix for this. If we go back into the main GUI, into the shop and client shop, what we can do in the add skins and the add trap is we will say if game.players.local player, so the player which this script is running on, so for the current player, local player, dot trap inventory, colon find first child, we'll do this for the skin inventory as well very soon, find first child, v.name, then, so if it's in your, if the skin that we're looping through, the trap that we're looping through is in your trap inventory, so you own it, then we can set the frames cost text to be owned, and the frames button image to be the green tick straight away, instead of having to wait for us to click the button. So, because this is running when the data is sent, when the data is loaded, we can check to see if you have that trap in your trap inventory, and if you do, then we will change it to say owned and a green tick, and we'll do another if statement to see if you have it equipped. So if game.players.localplayer.equipped trap.value equals v.name, because v.name is the name of the trap. So if you have this trap equipped, we can say frame.cost.text equals equipped, and frame.button.image equals green tick, just like that. So it's going to instantly say whether you own it or whether you have it equipped. Now I'm going to copy these two if statements. We're going to go, oh, my bad, I've done the trap one in add skins, so I need to change it to skin inventory and equipped skin. Let's take these, copy them, let's go to the add traps one and paste them into add traps, but change skin inventory to trap inventory and equipped skin to equipped trap. Okay, so what it's going to do is it's going to instantly check to see if you own the trap or the skin, or whether it's equipped, and if it is, it will automatically update the frame to say whether it is owned or equipped. Now I'm going to publish the game again and go check it out. So what should happen is it should instantly show me my loaded, owned and equipped skins and traps. So let's go to the store, and there we go, straight off the bat it says, okay, you've got the Shaggy Man equipped, because that is what we did equip in the last time we were in the game about 2 minutes ago. And also it says that we own the ghost, and also that the invisi trap is equipped and the yellow trap is also owned. So if I go and buy everything, buy, I'm going to equip the ghost and equip the red trap. Now I'm going to leave the game and go back in. Now if you're testing in Studio, sometimes it might not save your data, and I think that's because the game is closing down before it's managed to save in time, because it's in Roblox Studio. This shouldn't happen in a real game, and it shouldn't affect you, because I've tested it quite a lot and it hasn't caused me any problems. But anyway, you can see that the ghost is equipped and the red trap is also equipped, and everything else is owned. And if I wanted to, I could change the equipped values, and everything else is becoming unequipped, but the yellow trap is now equipped. And now the invisi trap is equipped, and the yellow trap is now owned. So it seems to be working really, really well. Okay, so now I'm going to show you how to make the skins and the traps appear in the GUI here in these grey squares, and we're going to be using viewport frames. Viewport frames allow you to render Roblox objects in a GUI. So in this case, we want to render the Piggy skin and the traps. So to render them, they need to be cloned into the viewport frame. And then we also need to have a camera which will be looking directly at those objects. So in Roblox, we can have an object called a camera, and we can tie that camera. We can set the viewport frame's current camera property to that camera object, and then it will be looking. We can set the C frame, like the position of that camera, to be looking at our cloned Piggy characters. So I'm going to show you how you can do that now. So we're going to go into the client shop script, and we're going to go up to the create frame function. So right now we've only copied our template in there. We haven't done anything to do with the viewport frames. So what we're going to need to do is we're going to need to take the object argument, which is the actual object of the skin or the trap, and we're going to have to clone it out and put it inside our viewport frame, because the only things that are put into the viewport frame can be rendered on the screen. So we can say local vpf obj, so viewport frame object, you can call it whatever you like, this is just the name I made up, equals object clone. Then we can say vpf obj.parent equals frame.viewport frame. So we're putting it inside that viewport frame there. So now that we've put our object in the viewport frame, we need to create our camera, which will be looking at it, because the camera is the thing that's going to render everything in the viewport frame on the screen. So I'm going to say local cam equals instance dot new camera cam dot parent. I'm going to put this inside the viewport frame as well, equals frame dot viewport frame. Now that we've done that, we can say if item type. In fact, yeah, sorry, I was just reading off my script. I forgot to. So what we're going to do, we're going to create a fifth argument, and this is going to be called item type, so that we can tell the function whether we're going to insert a skin or a trap. So in the add skins function on line 54, that's where my line is, it might not be on your line 54, but where we're calling create frame in the add skins function, we're going to add that fifth argument, and we're just going to add a string. We're going to call it skin, just like we did down here in the by item, so we can tell the function that we're going to be adding a skin. And you'll see why. It's because we need to make the camera look at a certain object, look at a certain part. So for the skin, we'll just make it. We'll make the camera look at the skin head, right? The head object inside the Piggy character. But a trap obviously won't have a part called head. So we'll just need to, because the object for the trap will just be a part, we can make it look at that part. The reason I'm doing that is because if you don't make it look at the head for the Piggy, then we won't be able to see it. It will probably just look at its torso, and we won't get a view of its head. So if we position the camera to be looking at the head of the Piggy character, we'll be able to see its face. Whereas it doesn't matter for the trap, because we can just make it look at that one part, because the trap is only made up of one part. So this is just going to tell us whether it's a skin or a trap. So if we go down to the add traps function, we're going to add that fifth argument in there as well, but the argument is going to be called trap. They're both going to be strings as well. So trap and skin. And once we've done that, we can then say if item type is equal, remember double equals because it's an if statement, is equal to a skin, then we can set the camera C frame to the character's head. Whereas else if the item type double equals is a trap, then we can just set the camera C frame to the object, because it's just going to be a part. Because if you think about it, if you go into replicated storage, .traps, and then look, these are just parts, right? They're just they're mesh parts, but they're still a part. It's one object, isn't it? So to set the camera C frame to be the character's head, I also have a video coming out on C frames very soon, so if you find it a little bit hard to understand, check that video out. It's going to be in the advanced series, but anybody can watch it. You don't need any prior experience for that one. So what we'll do, we'll set the C frame. C frame is basically position with rotation. So in this case, we're going to position the camera to be just a little bit far out from the player's character so we can actually see them, but we're going to be pointing it towards the player's head, so it's going to be rotated towards their head. So, little example here, if we've got, imagine this is the character, really badly drawn, but imagine this is the character. We're going to put our camera around about here, about 5 studs away from the character, and in fact we'll put it around here because it'll be up in the air a little bit, and it's going to be looking at their head, so it's going to be angled down this way. So if that's the camera and that's the Piggy character, it's going to be looking at their head, because normally if we didn't do this it would just be looking at their torso. So we're going to do it like this, and to do that we're going to say cam.cframe equals cframe.new, and this cframe is going to be object, because it's a character, we know that the object is their character model, so we can say object.head.position, so the position of their head, with, and we're going to add on to that, we're going to add on in the direction that their character is facing. So currently, if you think about that diagram again, if we've currently got their head position, so the camera's around about here where the arrowhead is, we need to get the forward facing direction, and we need to multiply it by a certain number to bring it out to around about here. So we want to bring the camera out to around about here. Currently the camera is here. We want the camera to be about 5 or 10 studs away from the character, and then we can point it towards the character so we can actually get their head in the view. Okay, because all of this stuff won't be seen because it's out of the camera's view. So we can say, inside of here, we'll do another pair of brackets, and inside of here we'll say object.head.cframe. So then we'll say .look vector. So look vector is a property of cframe, but it's actually a position value. This probably might be making sense, but if it doesn't, as I said, don't worry, I'll have a cframe video coming out. Multiply that by 5, and then what we can do is we can add some height to it, so about 2 studs of height. Okay, so I'm adding 2 studs of height because I want it to be, the camera just to be a little bit higher than the player's head, so we can look down on their head, and that just gives a better experience, and it fits more into the camera frame. And then, so this part of the code, this first part, is just positioning the camera. So what we've done is we've positioned the camera. Well, we firstly got the position of the player's head, which is around about here, right? If you imagine this is the player's character, and this is this is the position of their head. We're then getting the look vector. The look vector is the forward-facing direction, so the forward direction, and that's a vector. So we're multiplying it by 5, so we can move. I can't get my words out. So we're moving this 5 studs forward. This is moving the camera 5 studs forward. So the camera was here, and it's now probably about here. We're then moving it 2 studs in the air. So now the camera is here. And the next thing we're going to do after this comma is we're going to tell the script where we want it to be facing, because the camera could be facing this way, could be facing that way, could be facing that way. So how do we tell it that we want it to look at the head, which is here? Well, that's what we'll do. So to do that, we can just write object.head.position, because it will then just point the camera towards the character's head. So that is going to set the camera C-frame to the character's head. Now, what about if it's a trap? Well, it's a little bit easier if it's a trap. All we need to do is say cam.cframe, obviously, equals cframe.new object.position, because the trap is just going to be a part. Now, if your trap is a model, it's made up of loads of parts, you will need to say object and then the part's name. So, for example, if yours was in a group like this, you'd have to say object.bear_trap.position. In fact, you wouldn't. You'd have to have a part in that model which is named the same throughout all models. So if you had multiple models, you would just say object.handle, and handle would be the main part, right, which is used by this viewport frame. which is where the camera is looking at. So object.handle. Sorry, no. So yeah, that's if you're using a model, right? So you'd say object.handle.position, right? So instead of saying object.position, you'd say object.handle. But if you're like me and you're not, you've only got one part traps. I'm using a mesh part, by the way, which is why I can make them look good. And just use one part because they're a mesh, using a mesh ID. So I'm just going to rename this to be bear_trap. So yeah, if you're just like me and they're not in models, they're just single parts, I'm going to say object dot position, because object is the part itself, because it will be passed to the function. And we're going to add on object.cframe.lookVector, so that's the forward-facing component. Multiply it by 5, so we can be, it's 5 studs away from the object, so that the camera actually is able to see it fully. And then we will say plus vector3.new020, so it's just a little bit higher up in the air, so that we can still we can get a nice view on it. Then we'll do a comma, and then because the second argument in a C-frame is what it's going to look at, we just need it to look at the trap itself, so object.position. So the camera will be facing the object. Okay, so now that we've set the camera's C-frame, we just need to set the viewport frame, its current camera property, to be that camera. So frame.viewportFrame.current camera equals cam. Okay, so now as soon as that current camera is set to our camera, it will start rendering the object in our viewport frame. So let's go ahead and test it out. Hope this works. I really hope it does. It would be amazing if it worked first time. So we're going to go to store. Oh yeah, we need to make that button work, don't we? But there we go. You can see we've got Shaggy Man, Piggy, and the Ghost. So all of our skins are loaded in, and all of our traps are loaded in as well. You can see the Invisi trap. It's kind of hard to see, but I can see it on my screen. It's because it's nearly invisible, hence the name Invisi trap. But there we go. We can now see our objects in there very, very nicely. Some people probably will ask, how do you make them spin? Good question. It would take a little bit more coding. I'm not going to go into it today, but you can probably look up how to do that. It involves having a loop which would repeatedly set the C-frame of the object to be moving around, or you could loop setting the C-frame of the camera to loop around it, but that is not necessary, and I think this looks fine as it is. It just requires less work. So that is how you get the characters in a viewport frame like that. So very, very nice. I am pleased with that. Right, next I'm going to show you how you can add the Piggy tokens to the bottom of the screen so we can see how much money we've got. So I am going to insert into the main GUI, I'm going to add a text label. And that text label, I'm going to call it tokens. And I will set the position of this text label to 1010, and that will put it at the bottom right corner of the screen, but you can't really see it. That is because it's positioning it from the middle. So if we set it to be positioned from the top right, the bottom right, by setting the anchor point to be 1, 1, it is now in the bottom right corner of the screen. I'm going to set the background transparency to be 1, and I'm going to set the text scaled to be true. I can change the font if I like. I'm going to change it to Gotham Bold, and I'm also going to change the size. I'm going to change it from offset to scale so that it scales with the size of the screen. So I'm going to set it to 0.15 so it takes up it's like a fraction, so 0.15 would be 15% of the screen on the x-axis, and then it's going to take up 1/10 of the screen on the y-axis. That didn't work for some reason. 0.15, 0, 0.1, 0. There we go, that's better. Then I'm going to change the text to whatever really. It's going to be updated anyway, and I'm going to change the text color 3 to a nice pinky color. Let's see what we've got. Okay, I know. I've got a saved color, so we'll use 255, 116, 134. Perfect. That's a nice color. So now that we've done that, we can start coding it. So if we go into the client main script, I mean, you could do it in any script really, but I'm going to do it in this one because that's where I've done the rest of the coding for this sort of stuff. So I'm going to create two variables. The first one is going to be the text label. So local tokens label equals script.parent, which is a GUI, wait for child tokens. Okay. The next thing I'm going to create a variable for is going to be the actual tokens value, which is in my player. So local tokens equals game.players.local player wait for child tokens. Okay, so they've got the same name, but they're in different places and they're different things. Because this one is the value with our tokens in the player object, whereas this is the text label in our main GUI. So now that we've got those two, what we can do is we can create some simple events which will, whenever the value gets changed, we can update the text of the text label. So very, very simple. We're just going to say, we'll do it here by the status stuff. We'll say, firstly, because the game will load and the because the game will load and this script. Sorry. What I'm trying to say is we're going to set up a changed event, a get property change signal, to change the text when the value changes. But it might not. We want to set the value, the text of the text label to its current value before we set up that event, because it might be changed before the event is running. So we can say tokens label.text equals tokens.value. And then we can say tokens get property changed signal value. So when the value property changes, we can connect it to a function, and that function is going to fire. And inside of that function, we can say the same thing again. Tokens label.text equals tokens.value. So if we load the game, it should immediately change the text to 0. So we shouldn't see 1337. There we go. So after 2 seconds, obviously because we had to do the 2-second wait for the script to load up, but it has loaded up with 738 coins. So that's obviously been taken from a data store that got saved last time. So if I go into the server, because you can only change your values, like your tokens value on the server, else it won't take effect. Let's change it to 110. Obviously you won't be able to see the amount of tokens on the server because it's client based. There we go, it says 110. So I leave the game. I'm also going to change the tokens text from 1337 just to nothing, so that it doesn't give a fake amount of coins that you don't actually have. Okay, it didn't seem to load for some reason, but it loaded the old value, but it didn't save the one from the previous game. I think that's because the play solo shut down before it managed to save it in time. So yeah, we'll see about that. But we have got the tokens working now, which is good. Okay, next we need to code the buttons, don't we? The buttons in the menu here, so that it loads the store, and also this close button here. So we'll begin with the close button, because that won't take very long to do at all. So we can go to the client main script, and at the bottom here, I'm going to create an event for the close button. So we can say scripts.parent wait for child shop, and then we can say dot wait for child close dot mouse button one click connect function. And then inside of here, very, very simply, we can just say, firstly, we need to see if you're in the menu, because you could close the shop when you're in the menu, or you could close the shop when you're out of the menu. So depending on that, if you are in the menu and you close it, we want to show you the menu screen again. But if you aren't in the menu, we just want to close the GUI. So we already know if you're in the menu or not, because you've got that in menu value in your player. So we can say if game.players.localPlayer find first child in menu, then we know you are in the menu. So because of that, we will say intro.visible equals true. We'll make that intro frame visible. And then also, because this will apply for whether you're in the menu or not, we will close the shop. So script.parent wait for child shop.visible equals false. So we're going to hide that shop. So we have just scripted the close button. Let's go and test it out. In fact, we can't test it out until we've made the shop store button in the menu work. So we will say intro, because in the intro you can see we've got that button called store. So intro.store.mouse button one click :connect function, and then we will say when you click that store button, we want to firstly hide. Well, we want to enable the shop. So script.parent :wait for child shop.visible equals true. And we're going to hide the intro, because if you're in the intro, we want to hide it. So intro.visible equals false. Right, let's go and try it now. So we play the game, and if we click on store, you can see it opens it up. The camera stays there because we're still in the menu. Still got that in menu value. So we can browse the store, and when we're finished, we're back in the menu, and then we can get out of the menu. In menu has gone away, and we can open the shop normally. If we want to click the button to close it, you can see it doesn't open the menu again. So very, very good. We have now managed to make the menu in the shop work. Let's just do one more test. We'll set it to 111, close the game, and click play again. Yeah, so I don't think it's managed to save the values in time because the play solo has quit before it's managed to save. I've never experienced that in a running game before, but okay, I'm going to show you a way to fix that problem where it doesn't save your data if you leave the play solo, because there's a chance it could happen in a real server as well. If you're the last player in the game, because we're the last player in the game in the play solo, the server can shut down before the script has finished saving your data. So to fix this, we can use an event called bind to close. So game : bind to close. Then we're just going to put a function in there, no connect or anything, just like this. So any code inside of here will run when the server is about to shut down. So when the last player has left, the server will not shut down unless this code is finished executing. So we can loop through all of the players that are left in the game. Like this, and if we just set the v to player and we copy this code inside the player removing and we put it inside of here and we just indent it like this, there we go, it will make sure your data gets saved before the server shuts down. So I'll show you once more. My data will appear, my amount of tokens will be very, very large because I've just tested that. But if we go in and we set my tokens to be 11, for example, and I leave the game, and I go back in, you can see it's successfully saved. It printed that it's successfully saved this time. We go back in, I have got, as if by magic, 11 tokens. So that is the data store problem fixed. One last bug I'd like to address, which I have found after testing the game, after I put the series out. It's not a big bug or a big game-breaking bug at all. It's just that sometimes it can bug out because if you reset when a game isn't happening and the map isn't loaded, then it will get through this if statement and it will try to drop your tools using game.workspace.map. And obviously there won't be a game.workspace.map because the map won't have been loaded yet. So to fix this, we can say if inside this humanoid root part if statement, we can say if player : find first child contestant. So if they're in the game currently and they've got the contestant tag, they wouldn't have it if a game wasn't in progress. And game.workspace : find first child map, then we just put these 2 lines in there to drop the tools, and we can put an end in there. So this is just an example of how, you know, bugs can pop up after you've made something, and they won't pop up for a while because that eventuality won't happen. So in this case, the eventuality was that no player reset themselves when a game wasn't happening, and that took a while to find out because it's not something that people usually do. But when they do it, if they do it, it would break your script. So that's how you fix a bug there, and that is a bug that we have fixed. So again, it's not a huge bug because, you know, the chances of somebody even resetting in the lobby are minimal. It's not like somebody would do that anyway, and I don't think it would break the whole script. It just wouldn't. It would cause a small error, but there you go. That's another bug that we have squashed. Right then, I think we do one last test and we'll be good to go. So let's just insert, 2 players should do. Okay, so I have equipped the Shaggy Man and the Invisi Trap on this account, so you can see that the Shaggy Man has loaded in, and if they press the trap button, there we go, there's the Invisi Trap, it's loaded perfectly, so everything does seem to be working, and no complaints from me. Let's just place another trap, let's get stuck in the trap, there we go, and boom. We've got one more thing. It says killed by the Piggy. I'm not too worried about that, to be honest, because yeah, I'm fine with that. Just if you're naming your game something different, so I don't know, like bacon or whatever, then you would want to go into your game logic scripts and your client script where it says, you know, player was killed by the Piggy, and change that to player was killed by the bacon, etc. But again, please be original when you're creating these Piggy games. Please credit me in them because, you know, I've spent a lot of time working on this series, so I think it's just right that you credit me in the video, in your game, or, you know, in the description that you've used my kit, so that others can know how you made it and can help grow my channel. Because I've said I put a lot of effort into this series, you know, biggest series I've ever done, and I've done it in the smallest amount of time that I've ever done before. So thanks for watching the series. As I've said, this will be the last one, because, you know, it's got to end at some point. You know, for me to go on and make even more series and more videos, I've got to stop making these ones because they take up way too much of my time. But that is everything for part 7. Please do like the video if you've enjoyed it. Please do subscribe. If you're interested in more videos, do check out my 23-part beginner series and my advanced series after that, because it will help you become a Roblox scripter so you can make your own games without me having to show you, because that would be awesome. When you know how to make your own games, it's awesome, because you get an idea, it comes into your head, and you can just make it straight away. So it's really, really awesome. And you can also make a lot of money from Roblox, a lot of money. So if you're interested in that, you're interested in learning how to make your own Roblox games, then do go ahead and click the subscribe button, share it with your friends, like the videos so I know you like them, and it's been a blast. Thank you for watching this Piggy series, how to make a Piggy game from scratch. It really has been fun making this game, and I'm glad you've had fun watching it as well. Do check my website if you have any problems or bugs to learn how to fix your bugs. I've also got a video showing how to fix bugs if you come across them and not to give up. And remember, you can become a channel member if you want to take the full source code and get a load of other awesome perks, which you can check out by clicking the join button on my channel. So, after all of that, I would just like to say a final thank you to everybody who has watched the series and everybody else who has helped me test. My channel members have spent an awful lot of time testing the game with me, even before I launched the first video, and I owe it all to them, so you know who you are. Thank you for that. And also thank you to Linda 1009 for developing the map as well. Much appreciated for that. So thank you everybody for watching, and I'll see you in the next tutorial. Cheers.